Hello, everyone, and thank you for joining us on today's Sensafili Sparring Partners webinar on Open RAN, the path to 6G. Our speakers today are Ravi Sinha, co-chairman of the Next Generation Research Group on 6G at ORAN Alliance and VP at Reliance Jio, and Monica Paolini, principal at Sensafili. I'm Kendra Chamberlain, and I will be moderating our webinar today. In Sparring Partners, we watch our speakers debate a topic live on video. We would like to encourage our audience to participate in the conversation. Please share your comments and questions using the chat function on the Zoom taskbar. All comments are visible to all participants, so please keep the conversation polite and respectful. And feel free to ask any questions throughout the webinar. Our speakers will do their best to address questions as they go along and as they become relevant to the topics being discussed. So no need to hold them until the end. And with that, I'll hand it over to Monica.
Kendra, thanks so much for the introduction. And as always, it's a pleasure. I enjoy a lot doing Sparring Partners. And today is going to be a particularly interesting one because Open RAN is a topic that, as many of you know, probably has been really crucial for me. I've been doing a lot of work. It's a topic I love. And today we're going to talk about the future of Open RAN. And this is part of the report that I'm writing, and where I want to look into not just is Open RAN going to be successful or not, but how is it going to be successful? How is it going to help us? And to take apart all the different parts that contribute to it. It's not just the fronthaul interface. It's a much bigger enterprise, a much bigger project. And that's really the evolution of the RAN is Open RAN. So it's not just a side fringe path. It is in my view, it's the evolution of the RAN. And so I am thrilled to have Ravi with me today, who is doing a lot of work, has been done a lot of work for a long time on this. But right now, what he's doing is especially interesting because he's looking at the future development of Open RAN as we go to 6G. And some of you might say, well, what is 6G anyway? Well, there is a lot of work going on, and we don't know exactly what it is because there is so much work going on. And so we're still, as every technology development, is what is that eventually will become mainstream and whatnot, not everything that you try to develop. So we're going to try to talk and cover what is being developed, what is new, what will be important. And so with that, as Kendra said, we welcome your comments and questions. So you can have a question, but you can also have a comment and get them as soon as possible so that we're more likely to answer them because we get them as we go. Said that, I would like to ask Ravi that many of you already know, but just in case there's somebody that doesn't know Ravi, why don't you introduce yourself?
Sure. First of all, thank you very much, Monica, for inviting me. Hi, everyone. I'm Ravi Sinha, co-chair of our ORAN Alliance 6G initiative called nGRG, Next Generation Research Group, as well as I work for Reliance Jio product development, as Monica said. So happy to be here. Very excited to share a lot of development within 6G domains. As you all know, that 6G is targeted for 2030, but we are going to see much more activities prior to 2030. So very excited to be here, and then step by step we'll go into it. So I will again pass the ball to Monica for the next round of questionnaires, and we'll go one by one with that. Thank you.
Thank you, Ravi. It's again, it's a pleasure to have you here. And I promise to all of you, it's going to be a very dense conversation because so many topics we have to talk about. Now, why don't we get started? So the title today is like 6G and Open RAN. So maybe you can give us a little bit of a sort of a general introduction. Obviously, Open RAN doesn't need 6G to get started. We're
Sure.
not waiting. However, there is a lot of things going on that are going to be 6G or are just going to be development that is not necessarily 6G, but still. So can you tell us a little bit about what's the relationship between 6G and Open RAN? And I understand it's a really wide question, but
Sure. So
it's a good way to get started.
I will try to answer based based on best of the capabilities I have. So Open RAN is almost known to everybody. And why we did Open RAN? Multiple factors engaged. As you know, that the cost, compliances, and then automation, cloudifications, and multiple other factors around it. And when we have gone to a traditional architecture to distributed architecture, it was important to start with, and Open RAN started with the splitting of radio units, which has gone from your CU north to south, CU to DU to RU, many to one, based on that. That was the major focus, and then we have started getting the advantage out of it. But that was the start of ORAN. Of course, with time, it evolved, and then especially ORAN Alliance has started working, and ORAN Alliance is the biggest stakeholder over here. We started working not only to the back halls or mid halls or front halls, but we also worked heavily towards the specifications, test requirements, certifications. Along with that, a complete framework. When I'm talking about the framework, means we are talking about infrastructure as a service, going south to north, then from there to platform as a service, then network function as a service, then automation as a service, and of course on the top, anything a network as a service, or you can say, and then at the top, a federated layer as a service. So this is how ORAN Alliance also kind of contributed. And of course, I will start with the mid hall and back hall, front hall, those kind of specifications requirement. Then from cloudification side, OCloud, you have seen. Then ORAN side, RIC, you have seen, for automation framework, and many more is on the way. Our teams and different work groups, they're doing an excellent job. Anyway, I'm no one to talk about their great work, but definitely I can always appreciate the kind of work they're doing. With time, I'm sure that every technology, every framework takes some time to evolve, and I'm seeing that evolution is coming. It came up with a front hall and mid hall splits, but then more and more focus I'm seeing towards the RIC side of it, towards the automation framework side of it. And I'm also seeing that since multiple vertical will exist to a common platform, so of course, OCloud and artificial intelligence as a service, these also will get the traction with time. Now I will switch over from there to from 5G to 6G. And 6G, as you know, that 6G is also a framework. 6G is a framework. It's a framework which has multiple components in it. Technology, of course, is specification defined by 3G. And in terms of solutions and anything which is other than specifications, of course, all our domain expertise are into the split architecture and distribution. So we are trying to map, okay, in terms of spectrum, in terms of bandwidth, in terms of solutioning, in terms of distributed services, in terms of slicing, many aspects, in terms of infrastructure as a service, platform as a service, and network functions and network as a service. How exactly the coming set of humongous bandwidth, heavy fat pipe, slicing, in true sense, a fully coordinated service and connectivity framework, or 2D kind of service-based architecture will take place. And everywhere, I think I'm seeing that 6G is taking that leap. I can tell you, started from the lower layers, the distributions. I will not go to the details because I will still wait for many things to be defined by 3GPP, but a lot of areas related to research, where related to architecture, related to security, native security, native, you can say artificial intelligence, use cases, a kind of a test frameworks or proof of concept frameworks, how exactly those things are going to change with artificial injection of artificial intelligence, machine learning, all those things you can see step by step. They we are evaluating those, and whatever we can do at the best of the capabilities, ORAN will take its steps, and we are already in the process.
Absolutely. And as you said, there is so much going on, and you're sort of providing sort of I've said the plumbing, not in a good way, you know, the foundation specifications on which you can then build on top. And this is especially important in Open RAN because you need to have multi-vendors working together. So if you are on your own, you can do whatever, but if you need to work with others, the specifications become play much more of a critical role. But at the same time, all of this is sort of like you can develop the specifications without really caring about 5G, 6G, or 7G eventually. So can you tell us, you know, what is that 6G is going to specifically contribute? What is that is going to make a difference, 6G per se? And then we can talk about, I think, I don't think we want to get stuck too much onto what is 6G or not, because it's important. What is important is the path forward, whether it's 6G or not. Well, so it's not all that important. I mean, it's the path that is more important than the 6G or not, the label.
Sure, Monica. With your permission, I would like to probably dedicate 1 or 2 minutes to the introduction of nGRG, and then I will move.
Absolutely, that's right. Let's talk about that.
Sure. So as you know that nGRG was formed last year, and we have a huge attention by the industry. Most probably, I'm seeing everybody is a member of that. And our ambition is to provide a forum to facilitate ORAN-related 6G research efforts and to publish research findings that is there for the first phase of our work, and leverage industry and academic 6G research efforts and determine how ORAN may evolve to support 6G and beyond. So actually this effort is something which is 6G and beyond. Considering regional research efforts, ITUR and 3GPP development, achieve ORAN sustainability from 4G, 5G to 6G and beyond, consider the impact of 6G on ORAN areas of interest. So of course, that is the ambition, and operations side also define the ORAN next generation research agenda and key priorities, organize regular discussions and reviews, and study interworking of ORAN solutions across different technologies, where we'll also talk about how the different layer of artificial intelligence is also kicking in over here. And then outcome, of course, publish white papers and research report for the time being in coming 5 years, in coming 3 to 4 years, and recommend appropriate actions through white papers. And once we are gaining all the momentum, then the different work groups will take charge. And all up to 2025, we are aligning with the industry partners and perform a high-level impact analysis for potential 6G technologies and trends. And midterm 2025 to 2027, based on the research findings, provide inputs to ORAN work groups and functional groups so that they can go to the specifications where ORAN is well known for in terms of solutions. And long-term, beyond 2027, align with the other 6G research organizations, SDOs, and programs through liaison via ORAN, and like going to the different SDOs as well. So here it is, nGRG research focus mainly related to sustainability, cross-domain artificial intelligence, management, native security, and native AI ML, architecture, use cases, and next generation research platforms. So these are the 8 points we are focusing on, and you're seeing there are different work groups aligned and assigned to that, and they're called research streams or research, and then every research team come up with the research report. So soon you'll be seeing research report being published in a month's time frame, and followed by the white papers as well, so that industry can consume. And then I will also say that from there, I will also come to 6G. As I said, what exactly is there in the 6G? So first of all, I think it is important to understand in terms of spectrum, because everything boils down to spectrum. What exactly will be the series of the spectrum? So when we talk about a terahertz communication, is that going to be the attention for future or immediate attention for 6G? Of course, sub-terahertz will be the focus. Over 1 terahertz, of course, that will be for the research. But at present, I'm seeing the focus is from 100 gigahertz to 300 gigahertz. That is the one spectrum. But then again, also, like in US and multiple other European countries, 7 gigahertz to 24 gigahertz is also another area of attention, because having that area and focus, definitely with having our telco assets and street furnitures and all, without adding a lot over there in real estate, we can provide the footprint easily available for 6G like 5G. Of course, I think 5G will be more focused towards the use cases, more indoor, but definitely you can see a lot in distributed fashion. Overall, I'm seeing that multiple alliances have come up. Of course, for US is NextG Alliance, and of course ours nGRG, like it's a global alliance where everybody is a partner. So I will not go to the details of the specification, but as you know that the traffic capacity for 6G is 10 gigabits per second, and of course peak rate is 1 terabits per second. So those are the two things. AI/ML is end-to-end, not only for the management layer, but also for the control layer and data plane layer, stack by stack. We need to have it, and I'm sure the industry is working into it, starting from hardware to firmware to software, and distributed edge and cloudification. All 5-6 layers are going to be at sync with time where the NTN or non-terrestrial network, terrestrial networks, and HAPS, high altitude networks, all three of them will be in coordination. So that is the vision. And of course, along with the vision, it is also important that what are the basic capabilities of 6G, which will kind of differentiate from 5G. So generally, like capabilities, like generic capabilities are always evaluated in terms of coverage, capacity, data rate, latency, quality of service, automation. So advanced capabilities, if you can see, deployment flexibility, energy efficiency, which is very important, native security and AI/ML infused advanced automation, resilience, robustness, dependability, EMF aware, network migration, quality of exposure, integrated ground, air, and space network, as I said, neural network based software stacks. And that is also going to the next level with the semantic communication and all that will also come in future. But then again, DSA, domain specific architecture, where FGRA and CGRA, these are the two architectures which will change the whole paradigm of hardware architectures. Support of smart meta surfaces for all the smart verticals and services, joint communication and sensing, visual light communications, next generation services, sustainability. These are a couple of things which are very important for all of us to kind of focus and move on with it. And I'm seeing that like it will start with the spectrum. Everybody has started talking on the spectrums, but you can see with time a lot as coming in that area. Yep.
Absolutely. And so let's start with the spectrum. You put a long list, and there's all things that we'll try to cover. I don't know if we'll manage to cover them all, but we're getting there. But let's start with the spectrum. So clearly there is a trend towards higher bands, and it starts with 6 gigahertz all the way to terahertz. Now, the question for Open RAN, and this is like a devil's advocate question here. Could we say that, as you go up in the frequency and you tend to have a smaller coverage area, is at that point Open RAN as relevant or as important? So do you need, especially if you have a small cell, do you need an Open RAN, or can you just get a traditional RAN? And again, this is my
Very,
devil's
very
advocate,
interesting.
because
Very interesting question.
I think that, Open RAN is really like, it's a new mindset for the RAN.
Sure.
Sorry, that shouldn't really matter, but I'm gonna let you answer that question.
It's a very interesting question, and not only you, Monica, probably all of us are always kind of asking that. But the question is Open RAN is only about the split architecture? I feel it's not. Because Open RAN is about, of course, about the splitting of radio. And it has got a lot of benefits. We have seen it with 5G. You'll see it with 5G Advanced and with 6G as well. And I'll tell you how. But then along with that, how about the cloudification? How about the automation? How about artificial intelligence going to the different layers of it? A lot is also embedded because we split things and we aggregated the main brains of the radios to one place. We somewhere distributed as well as centralized the pieces which is supposed to be at the telco edge and supposed to be at the metro and regional edge. We distributed in a cloud fashion. When we did, we have also got the capabilities to really monetize the data, process it, and put it in a way which was never done earlier. So then again, as I said, that there are three different bands, right? When we're talking about 7 gigahertz, 25 or 24 gigahertz. Then second one, we're talking about 100 gigahertz to 300 gigahertz. And of course, anything above 1 terahertz. So I think in the beginning, if you see coming like 2030 onwards for 5 years, as like you have seen the trend that like it will start with the standalone with the SP architecture, but then again, since the major focus is that the telco infrastructure shouldn't have overburdened. So then, of course, I'm seeing that this particular band will have a lot of benefit if you go for distributed architecture. Of course, like when we are going for anything above 100 gigahertz, you can see a mix and match based on whether indoor versus outdoor. And again, FWA versus access. All those kind of combinations will have a different kind of distributed architecture versus a consolidated architecture. And of course, a 1 terahertz and above as well. So three different sections will have a different approaches. But then again, one thing which is very beneficial is how exactly your RIC part of it or RAN intelligent controllers, on the top of it, policy controllers, the core aggregations, and then all your artificial intelligence going the top, also in 3 different layers: native artificial intelligence, cross-domain artificial intelligence, and federated artificial intelligence. How exactly they are also aligned, and you're able to align these 3 because you're distributed. Definitely. And of course, when you'll be consolidated with time, you'll see that all of them will be converging in a different fashion over there as well. So I do see there is a lot of value with the distributed architecture, but then again, with the different bands, you can see a different approach.
Absolutely. And I think that what is really crucial and what I keep hearing from operators is that the main attraction of Open RAN is actually not the cost savings, which is obviously a good thing, but it is the flexibility. And so the fact that you can have centralized, distributed, the fact that you have a logical split that allows you to either have the equipment all in the same place or not. So it doesn't have, so you can do whatever, but it just allows you to have a common platform. Exactly. And you can do terahertz, 6 gigahertz, or 800.
Yeah, things can coexist.
Yes.
Yeah, with a common controller, with a common controller, with a common CU, with a common RIC and automation framework, artificial intelligence frameworks, and data monetization on the top.
Which again, yeah, if you want to have anything automated, you want to have a common infrastructure. Sure. I mean, I guess that in fact, a bigger issue is legacy networks rather than terahertz, in a sense that, legacy networks, you cannot just go and have Open RAN because they're already there. So, but before we go into that, there is a question which is related to this, which is about integrating Open RAN into non-terrestrial networks. And this is a question from Evan. Can you provide advantages for platform like xApps, Leo, or Mio for using Open RAN? Which I guess is a similar question, but again, it's a different tangent on the same spectrum question.
I'm sure. I think if you think about non-terrestrial networks and xApps, I'll go to non-terrestrial first because xApps is still evolving and it is at its, I'll not say nascent, but a stage where not a lot of regulatories or those kind of standards are being claimed. But yes, NTN side, if you think about all the major NTN vendors, all the satellite vendors, if you can see their satellites are slowly getting aligned with 5G infra or 5G standards. I'm seeing with time, in a couple of years, they'll be more aligned to a standard 3GPP compliant satellites working as a floating mobile radio. So that is one first. And then once that piece is done, then figuring it out that they have multiple orbital layers, you know, that like we know that like it is low stationary or like, sorry, lower orbits or LEO compared to MEO and GEO. So LEO also, you'll have a millimeter wave based satellites for access versus Ku and Ka band, Ku and Ka band based satellites and others. So over there also, you'll see a lot of coordination. So the density of millimeter wave satellites will be many folds more than Ku and Ka band satellites. Compared to that, if you think about the GEO satellites, their numbers are very limited. So based on that, I'm seeing a lot of possibilities where aggregators, maybe a set of aggregators like in background, working to coordinate with these satellites in terms of user plane, control plane, and management planes. And of course, in that way, you can minimize the Earth station linkage. And in that way, Earth station linkage is a very costly affair. Like shooting down a one band dedicated, and if it is one-to-one, then think about it, 6, 7, or 13,000 of those satellites from the different, from one operator versus the other, those numbers vary. But those many number, like just shooting down those beams and dedicated beams going, and every time it's coordinating with the core and other radios or the operator's radio is also a big hassle. So are distributing and aggregating in a space, and of course shooting to a much fatter pipe going to the Earth station and doing the mobility and aligning it in a way so that it is much more energy efficient and resource efficient will be the way to go. Along with that, multiple coordination between satellites when they are handing overs and all, and having those kind of arrangements where multiple satellites can minimize those control plane messages can also be one of the possibilities. So there are many more. So I'm seeing much more will go there. But then again, all those satellite companies are the part of ORAN as well as multiple 3GPP and all. But I'm seeing that with time, they will take more, they will show more interest to be more compliant to 3GPP as well as ORAN and go as per the commercial standards. Yep.
We have another question. This is from Bharat, and I'm going to add something to it. And the question is, does the ORAN Alliance in nGRG likely to include support for non-3GPP technologies like the E2 interface? And I actually would like to add something on top of that. So in a way, you could see that the Open RAN becomes a little bit more independent of the air interface. So you could be having, you know, Wi-Fi onto it. I mean, and I'm not saying, but, you know, there is a sense in which you can go even further in the sort of opening up, or at least because you have a more flexibility, you can integrate different interfaces better.
Sure.
So what's your view on that? That's kind of another really rough.
I'm seeing a lot of work going on. WVA is one, Wideband Alliance is doing a lot with Wi-Fi getting aligned with 5G and in future 6G, 5G at least I'm seeing. So there are possibilities, and I think that practice is being done for the last 6 years, I know very well, because I'm engaged with multiple of those activities where how Wi-Fi and LTE and then later on 5G can coexist. And there are a lot of standards and others are kind of in place. But again, it has not reached to a level where like Wi-Fi compliance is an interface compliance is coming to 3GPP in a commercial way. I think that is the time, and once they open up, we can also open up. But in terms of some of the cloud automation, recompliances, those are something which is independent. So where, but then again, I'm no one to comment on that. I will always be kind of looking to all the work group owners of ORAN Alliance who can tell. But I'm sure that there are a lot of initiatives also being considered. How those things are aligning, what is the status? I think I will always wait for those work group owners or co-chairs to put a statement there.
Absolutely, and sort of following up, you mentioned this. This is something I have to ask you, because this is one of my, I think the most fascinating 6G development is RIS, the ability basically to use reflection to improve coverage, and using passive transmission, which is very energy efficient. So I think it's really cool thing. And you mentioned it earlier. Again, how is that going to work, or is it going to work?
So you're talking about RIS, right? Reconfigurable
Yes.
Intelligence Surface,
right?
So of course, RIS is something where I'm sure that 6G nGRG Alliance is also very much interested, and we are also, and I'm seeing multiple vendors are also working into that area. Especially, just see, nowadays the access is not only the focus, but FWA is also the focus. Fixed wireless access is the focus. And in all those areas, line of sight versus non-line of sight is equally important. And when you have a non-line of sight, and in any ideal conditions, you will have a line of sight, but non-line of sight is very kind of common, especially for FWA cases. And then in those cases, it is important that we need to have reflectors in place, and that is also which is kind of doing that reflections or reprogramming those based on the kind of indexing you're looking for. And I think we are working forward with multiple of the parties to have something where edge can be a part of the RIS fully integrations, so that we can use it for FWA for any other access and backhauls, and get the efficiency improved many folds better, with a better sustainability and power consumption as well.
Absolutely. So, yeah. Actually, why don't we talk about? Oh, sorry, you were saying something.
Yeah. So that area is going on, but again, like the standards and RIS and all, RIS is again, it is something where like a lot is needed to be done. But again, I know that industry is giving it a high priority. With time, we will see a lot is coming, because that is a very cost-effective way to enable the or to improve the efficiency of non-line of sight, which will be the case for FWA and CPE communications and access points as well. So, yep.
No, absolutely not. And so you also mentioned energy efficiency, which is clearly a crucial topic. And and with respect to Open RAN, you can argue both ways. And I've been arguing one way, but there are two ways to go about it, and say, well, if you have multiple vendors, it's more, it might not be as energy efficient because of the multiple vendors. On the other hand, you can say that it's going to be more energy efficient because there is more choice and there is more competition and more flexibility. What is your view, and how do you see that evolving as we move towards 6G?
Energy efficiency and sustainability is going to be the most important factor. If you can see the power consumption, what we have, and then comparison of 4G to 5G, there is a huge improvement in terms of per bit energy consumption. But then again, it needs a further kind of a downtrend, especially for energy consumption. And as you can start with the real estate, think about like your outdoor you can say the rooms where the equipments are stored, starting their energy consumption, starting from the cooling to the consumption of baseband radios to the power amplifiers to the antenna elements, massive MIMO. They all are they all needs a lot of juice in terms of energy. And again, how we can inject the different type of hardware which can reduce, especially starting from the silicon chipsets, and then on the top of it the cooling, like water cooling. There are different methods coming over there. So all those things. Then again, realigning the radio stations and stacking to use the minimal space rather than multiple room spaces and reduce the power consumption over there. Then on the top of it, I will say that, and by the way, like close to 50 to 60% power consumption is because of the radio, and mainly because of the power amplifiers. Having a lot of improvements there. They are still doing it, but of course, a lot is needed. And that's the reason why all kind of material we are using for power amplifiers over there also, there are a lot of innovation going. From there, I will go to the coordination bit among all the base stations and the SON concepts, switching on and off the power, switching on and off the slots or the symbols. All those areas is seeing a lot of improvements there. And of course, intercoordination among multiple cells to minimize the power of the resource blocks or RBs, and is also going to kind of reduce the interference as well as reduce the power consumption as well. And then again, the SON concepts, and then using, even not only that, even when we are transferring data from one place to another place, whether we like in future we'll be using semantic communications and all, which will reduce the traffic by 80% based on some of the projections, but those things will come with time. But at least up to 2030, I can see that a very smart fabric of SON is coming. I'll not say SON now, it's a sustainable fabric is coming. Where NetConf and Yang-based models will be very popular with the standard KPIs anybody and everybody can use to better coordinate with the cells, better coordinate to switch off or switch on the cells, slots or symbols, and move forward with it. But along with that, when you move data from one place to another place, like you also need to, like at present it is not yet considered, but what data centers I need to move to minimize the power consumption and my ideal traffic as well. And then also using artificial intelligence, going to the stack by stack and figuring it out that during the certain combination or choosing certain combination at the top layers, how we can best utilize the stack and minimize the uses of resources in terms of memory, in terms of you can say storage, networking, and compute. How to reduce those areas. So there are also some of the work going on, and you'll see it is coming in a huge way. And I can only, in a given time, I can only give you the very top level, but a lot is going on over there.
Absolutely. And actually, I did a whole sparring partner hour on Open RAN with your colleague, Open RAN and energy efficiency with Alex Troy. And it's really, you know, it's really fascinating. What I wanted to ask you though is, you know, as I said, a lot of the power consumption is in the radio. However, and we're gonna try to reduce power consumption there, but there's just so much you can do. But there is a lot you can do. I think more you can do at managing those resources.
Exactly.
And that, you know, sleep and other things. And so, as you said, you know,
and cloud resources as well, Monica, like cloud resources, because now
yes.
everything is going on cloud. So the data center energy
Exactly.
consumption optimization, and again, as I said, the resource, minimizing the resource as much as we can.
Yeah, absolutely. So, you know, just to see where is the biggest source. So there is a lot that can be done at a sort of higher level, the management, and that's where automation comes in. And now you mentioned sound, but isn't Rick going to be basically taking over that part, or is it just both of them?
So Rick is changing shape, and of course, I think Rick will be one of the domain orchestrator, of course. But I'm also seeing the bigger version of Rick, maybe end-to-end orchestrator or SMO, where multiple Ricks with a very specialized set of slices taking care of those. Multiple of them are coordinating among themselves. Along with that, the SMO is also handling the distributed pieces of core as well. And they all go to the end-to-end, because that end-to-end is having the federated hook-ins, or you can say the catalogs going north for the corporate or the governmental or other kind of alignments. But the cross domains also can take care and can leverage all these multiple rigs or smart rigs in such a way that the overall intelligence of the network has gone up many folds. So yes.
What do you mean by multiple rigs? This is a new kind of, that's because, okay, there is the non-real time, near real time. So it's two of them. Now you said multiple. What is it? What do you mean there?
So Rick, what exactly is Rick? Rick is like when multiple CUs gather their data and then they go to the Rick side of it, and Rick has got generally one is just getting xApps to RApps, like, and again split into near real time and going to the non-real time. But in 6G, you'll also add something called real time Rick. So then you'll have 3 layers. So real-time Rick, near real-time Rick, and non-real-time Rick. So of course, the intelligence will come further south. So intelligence will come in terms of management. I'm not talking about stack and all. It's already, it will be there up to the radio. But then if that is the case, then of course, you'll be seeing many-fold more intelligence going to this multi-layer of Rick. So then this is one. But then if you think about the header or the non-real-time Rick, that is there for a region or a cluster, right? So then you think about a rig which is handling the radios, but then another rig which is dealing or smart rig, or a super rig which is also dealing with the automated vehicles like auto world, like their RSA, like radio units, and then their like county traffic networks where it is also contributing, and lot many others with the hazard conditions and all. So now you'll see those rigs, because when the car is moving, it will also be using your telco resources as well as the RSU, roadside units as well. So you will see in a multiple ways for HAPS, you'll have different kinds of, but when they intercoordinate and then they merge to a big cluster, to a zone, to a state, when they go and then communicate, they need to be fed to a huge end-to-end, because ultimately the federated will plug in over there where they have the visibility of all, which means NTN, TN, and that is also in cluster by cluster way based on the policy and agreements and MOU. So you will see a multi-layer of that development with time. And the time will be short, like, because more and more service-driven applications will demand those, and you will see those.
Absolutely. So first of all, I need to file my complaint about the acronyms. The nREC, which is two, like one is small. I mean, the non-real time and near real time. I think that we could have done better of having two things that didn't have N in the same place. But at the same time, I'm relieved to, because that was actually always my question. Is like, we have near real time, which is good, but what about real time, which eventually that's where you want to go, and clearly that takes more time. Now, how do you see in terms of, you have an operator that deploys Open RAN, and do they need to have REC? So can you walk us a little bit through which way do you want to go with the different RECs and with the different xApp and AirApps? And I have a question about the apps for real-time REC. So how does all of this fit together? in
Sure,
real life?
Monica. Of course, I think there are two parts of it, right? I think one is your greenfield deployments, and another is your brownfield deployments. Greenfield deployments, all the latest and greatest you have. You can go with the ORAN and you can have the automation framework completely in terms of real time, non-real time, and near real time. For the time being, near real time and non-real time, you can have it, and on the top of it, you can have cross-domain and federated AI on the top. You can do that. But in case of brownfield also, if you think about Open RAN specs and all, it is not that difficult to comply the traditional radios to talk to RIC, because anyway, traditional radios also pass all those the standard KPIs to the upper layers, BSS and all, right? So and nowadays, I think every big vendor also, they are vouching for compliance tool, because they are seeing the importance and the value of RIC. So once they also comply, then it is very much possible to have a RIC fully capable to handle a brownfield as well as greenfield both. But on the top of it, I think the basic advantage is in that way you'll have a centralized policy managers, which can also take care of a lot of things over there. And then some of the core functions, NSSF and multiple other things, NWDAF, and all those things will also come and coordinate with the top layer of RIC as well. And you can see, but those are the thoughts. A lot of work which is kind of going in splits, but I'm sure with time you'll see a lot coming there as well.
Yeah, and I think that RIC is another great thing about the evolution of the RAN, because again, it provides a common platform for different operators to work with different vendors, different applications. So it just allows you gives you the flexibility to automate, to improve and manage in a more effective way. And then every operator will move at a different pace. Sure. And it will just use different features. So I think it's the flexibility allows you diversity in terms of what is it you want to do. And not everybody wants to do the same thing. So I think that this is, this is all very interesting. And, I guess you could have a situation where an operator might have a single vendor network and still use RIC. I don't know whether you'd be able to use RIC, however, with the legacy infrastructure, because that might be a little bit more difficult, right? And it's not.
It all depends what kind of value add it is doing to the networks and how forward thinking the owners are. Because just think about it, at present, if you have a legacy network, definitely for future you will have the modern and next generation network as well, because slowly you're migrating from the old infra to a new infra. Then you would like to have automation framework which will be working in a good way or efficiently for your upcoming or the new networks, but also it can integrate if you see a value to your existing legacy ones. But then again, how much hassle you have and how much compliance or additional integrations you're looking for, it all depends the value you're seeing. I think when you include more and more services on the top of connectivity, you see more and more value going to that automation framework.
Yeah, no, absolutely. I was looking at, there's so many potential topics to talk about, but let me ask you another one, which is sort of tied to 6G, but not completely, and it is about the chipset choices and accelerating. So at the very beginning, we thought, well, we just use any hardware will work, and then it's like, no, hold on, we need to accelerate. Now it's like, well, there are different ways to accelerate. And maybe we need to go back to some chipsets that are more, optimized for what we're doing. Which is still, so there is a question that, so the hardware is still different, separate, logically separate from the software. So you still virtualize, but doesn't mean that the chipsets shouldn't be optimized. So how do you see that going? Because clearly that is important. It's important from a energy efficiency point of view, from performance point of view. I hear a lot of operators that want to have more choice, how is that going to move? How do you see that moving forward?
And the chipsets also, think about it, like 3 bands, as I said, like 7 to 24. That is something where the existing chipset fabric will be fine. Of course, a larger bandwidth, but again, once you move above 90 gigahertz, then all the silicon fabric you're using need to change. Indium phosphate or gallium nitride, these are the GaN and INP. These are the 2 type of material you'll be using because they are more friendly or suitable to these bands. And of course, like this was the fabric, but then again, what is architecture? Because hardware can't be like once you design it, it is fixed. The nature is not going to change. No, even if you can make it more efficient in many ways, but once you made, you can't change. Is not the way to go. So with time in architecture also, like you can say DSA based architecture where dynamically you can program the nature of the hardware. Over there are 2 flavors. One is called your FPGA and it's called fine grain reconfigurable architecture, or CGRA, or it's called coarse grain reconfigurable architecture, where you will have the blocks, the entire die will be a set of blocks, and every block can be programmed to work as a memory block, or can be programmed for a compute block or networking block, right? So in that way, like you can do the changes on demand, and that's the reason how like 1U unit versus 7U unit, you don't need to, even if you need 1.5U, then you need to add 1 extra U on the top of 1U, right? So all those things are also going to change. So I'm very hopeful that the material, and then on the top of it, you do have your architecture, and of course, on the top of it, the cooling aspects of it. These 3 will change the game. And I still feel that now we talk about 24 core or 36 core and those kind of cores. Now we are talking about 512 cores or 1024 cores. And each core can be a compute core, can be storage, can be a network core. So it's like that. So things are going to change over there. So silicon is going to be a game changer, starting from 3 to 7 nanometer. Also device side, also CPE side, also there is a lot changing. And now we are talking about the devices. So if you talk about devices, then you can think about where it's all about massive MMTC kind of communications, where like those devices will be $1 to $3 range. So of course, a lot is going to change in terms of the whole fabric, how they're stitched together. Yeah, including
yeah, and I have to say that this is where, you know, the sort of Open RAN approach is going to have a major impact way beyond the Open RAN, because you know, by decoupling, by having, you know, a virtualized hardware and promoting multi-vendor disaggregation throughout end to end, it's not just CU and DU. What you do is you encourage the development and exploration and commercialization of different solutions.
Sure.
And you know, as you say, you're going to have more cores, but then you're going to be able to manage them better. So it's not just, well, it starts with the hardware, but you know, it's just the way you can and the kind of flexibility and ability to change and manage that is going to be really crucial, I think. So there's a lot of very exciting things moving forward, which is above and beyond the sort of like the initial multi-vendor. So I think that there is a lot of value to that, but it's clearly more than that. Or the multi-vendor and the open interfaces are the first step towards this sort of a general, which is what I call in the blog thing that I send the link for everybody, the Open RAN without a capital O, in the sense that it's more, you know, it's getting bigger anytime, you know, and by the day, because there is much more. It's just the transformation of the RAN. Now, what about, you know, use cases that that you can see that Open RAN is going to facilitate. And in a way, it's sort of like, it seems like, should we think about it as different things that Open RAN can do when Open RAN is everything? I mean, Open RAN is just the way the RAN is going to be. So, maybe there is nothing really special because everything is in cup, but maybe
Open RAN is a framework, right? So Open RAN is a framework, as we said, that we started with the split, but then now it has become a framework. How exactly the framework means, like you started with those modules being split, but then those interfaces defined. Then automation framework, including RIC and multiple layers of those RICs. Then the cloudification clouds. And of course, it can be multiple other variations as well. And on the top of it, the federated AI, which is also developing, artificial intelligence as a service, is also developing on the top. So it's a complete framework. And out of that, different SDOs, they have a different role to play, starting from 3GPP and multiple others. So I'm seeing it in a bigger way. But yes, in terms of use cases, I can tell you that, like, the overall fabric, how exactly those use cases will be enabled in terms of cognitive networks. Cognitive networks means it's much more aware of what the network is doing and how it can change shape and size and the behavior and nature of connectivity. I think that is important. Connected sustainable world, means not only connected with the terrestrial, non-terrestrial, and HAPS as well. And along with that, more energy efficient connectivity. And as we have discussed, in multi-layers of that, and in an efficient way to intercoordinate and do those things. Network compute fabric. So the entire cloudification is all about that and how to better utilize in terms of hardware, silicon, cooling, and then the storage, movement of data from one place to another place with a minimal distance traveled, including the data sovereignty and all. Programmable physical world, as I said, RIS, we have configurable intelligence surface. We talked about multiple other combinations of that. And limitless connections, as we said, if three of them will come, definitely you will have at least one coverage from one out of three is available minimum. Connected intelligent machines, like including cobots or humans, as well as all the machines, which is the part or robots and then the artificial intelligence fabric around it. The Internet of Senses also, because that is the front face of it for the intelligent network fabric. Digitized and trustworthy systems. So those are some of the ones which will give every use case a new meaning to it. And I feel that all of them, and of course, the use cases, of course, like I'm seeing whether it's automotive, whether it is automation frameworks for warehouses, manufacturing. These are a couple of e-health going to the next layer. And then, of course, your e-agriculture, or agri-tech, and of course finance. One thing which we are not counting at present is also security. So security with the injection of quantum is also going to be a big threat. And bank and financial sectors also need. So you can see that with 6G, you'll see a lot of encryptions also very much compliant and capable to deal with these kind of challenges as well, like quantum encryptions, QKDs, and QFC. Those kind of concepts will also be a big game changer over there as well. So use cases, I'm sure that with time you'll see, but metaversarial fabric will always be the platform to enable those use cases. That I'm very sure. And that metaversarial framework need to be flexible enough so that quickly the same platform you can use for agri-tech, or you can use for manufacturing, you can use for aviation, you can use for transportation and warehousing, or you can use for or any other smart platforms like entertainment, as you could say, like AR, VR, or XR based, but taking it to the next level. Yeah.
Now we have a few more questions, but we're not going to be able to go through all of them, but I want to ask you a final question.
Yep.
And, you know, whenever you see a market forecast, they say it's going to be X percentage of the RAN is going to be Open RAN in 3 years, 5 years, whatever. What do you think is going to be in the long term? And my view is that at the end, the distinction is just not going to be relevant in a way anymore, because everything is going to be open to some extent, not necessarily in the same way. So to me, Open RAN, you know, in the long term, the distinction doesn't make sense anymore.
Yeah.
Because it's all open. What is your view on that?
So in terms, just see, if you consider only Open RAN means only split, then also like you are seeing, like now ORAN has recently has gone public that they have built a page where you can go and see in which area where exactly ORAN is deployed, and you see that those numbers are also increasing. So you see a great future there. Number of OTICs has also gone more than it was 12, but now it has gone even much beyond that. I don't know the exact number, but that number is also increasing. That tells you that people are interested, people are going for compliance so that it can be deployed for future. So in that term. But if you consider Open RAN as a complete fabric, including the split interfaces, automation frameworks of RIC, then your cloud and anything on the top, whether it's federated or cross-domain AI, every sense, then with time, everything will be Open RAN, I think, based on my understanding, because I don't consider 6G to be deployed without intelligence fabric totally going not only to the management, but also going to the user plane and control plane. And this is, I'm only talking about just the connectivity, but on the top of it, services, because now it will be connection aware services. So of course, any kind of policy management, any kind of you can say a user experience based approach for the services. Everywhere you need the smart intelligent controllers of connectivity is also coordinating with the service controller, artificial intelligence controller, so that both of them are at sync and you can get the best of the experience end to end. So I'm seeing everything is a part of it.
Yeah, absolutely. I'm very glad you're saying this, because sometimes it's like, you know, is it going to be 20, 30, whatever the number is? I think it's just like it misses the point. It's like, this is much wider. It's, as you say, it's a fabric thing. So, well, thank you so much. It's we're closing on a very positive note that resonates very well with the way I think about it. Over to Kendra, but Ravi, thank you so much, and thank you for all of you in the audience for questions and your attention.
Sure,
so thank
thanks
you so
a lot
much
for having me. Yeah.
Thank you, Ravi, and Kendra, back over to you.
Okay, great. Thanks again to our speakers for that great conversation, and thanks to our audience for those wonderful comments and questions. A recorded version of today's webinar will be available at sensiphilly.com in the coming days. And we have 2 upcoming webinars. The next one is September 27th on sharing 6 gigahertz spectrum, and another one on October 19th on getting RIS off the ground with AI and machine learning. Registration for those will be available at sensiphilly.com as well. Thanks again, and we look forward to seeing you at future events.